Hello everyone, I am Dr. G. Purnachandra Rao from the Department of Electronics and Communication Engineering. In this video, we will discuss an important special purpose diode called the tunnel diode. This topic is part of special purpose diodes in electronic devices and circuits. Tunnel diodes are widely used in high speed and high frequency applications. In this session, we will learn the construction, working principle, characteristics, advantages, and applications of the tunnel diode. A tunnel diode is a heavily doped PN junction diode used for low voltage and high frequency applications. It has a two-terminal device where P-type act as anode, N-type act as cathode. It is also called the Esaki diode, named after Leo Esaki, who discovered the tunneling effect and received the Nobel Prize. The key concept here is the tunneling effect, where electrons pass directly through a very thin depletion region. Common materials used includes germanium, gallium arsenide, silicon. And here you can see the symbol for tunnel diode. In a tunnel diode, the doping level is extremely high compared to a normal diode. So because of this heavy doping, the depletion region becomes very thin. Here you can see the clear comparison. In the PN diode, the depletion region is very high comparatively tunnel diode. So this is very thin. So with this help, electrons can easily cross the junction. This thin barrier enables the quantum mechanical tunneling effect, which is the key feature of this device. Let us compare the tunnel diode with a normal PN junction diode. So tunnel diode is a heavily doped while PN diode is a moderately doped. Depletion region is very thin in tunnel diode. Tunnel diode shows negative resistance, which is not present in normal diodes. It operates at much higher speeds. Because of these differences, tunnel diodes are used in specialized applications. Coming to working principle, the overview is the working of a tunnel diode is based on the tunneling effect. Due to the very thin depletion region, electrons can directly move from the conduction band of N side to the valency band of P side without needing high energy. So this happens even at very low voltages, which is why tunnel diodes operate at low voltage levels. So when a small forward voltage is applied, electron starts tunneling across the junction. So current increases rapidly. This region is called the tunneling region, where current rises quickly with voltages. As the voltage increases slightly, the tunneling effect becomes maximum. Current reaches its peak value, known as peak current. So this is the point where maximum tunneling occurs. When further increase in voltage, so that means when voltage is increased further, as a alignment of energy band decreases, so tunneling reduces. As a result, the current decreases even though the voltage is increases. So this region is called the negative resistance region, which is the most important property of tunnel diodes. When large voltages are applied, so that means voltage is increased further. So normal diode conduction starts, current again increases. So overall the tunnel diode shows increase in current, then decrease, and then increase again. So this unique behavior makes it very useful in oscillators. The VA characteristics of a tunnel diode clearly shows peak point, valley point, negative transition negative resistance region. So the peak point is nothing but the maximum current. Valley point is nothing but the minimum current. This negative resistance region is between peak point and valley point. So in this region, voltage increases and current decreases. So this negative resistance property is used in high frequency oscillators and amplifiers. Now let us look at the advantages and disadvantages. Coming to advantages, very high speed, low power consumption, low noise. Coming to disadvantages, difficult to manufacture in larger quantities, limited applications compared to normal diodes. Despite limitations, they are very useful in specialized circuits. Tunnel diodes are used in high-speed switching circuits, logic memory storage devices, relaxation oscillators, FM receivers. So they are especially useful in circuits requiring fast response and high frequency operation. To conclude, a tunnel diode is a heavily doped PN junction device that works on the tunneling effect. Its unique feature is the negative resistance region, which makes it useful in high speed and high frequency applications. Thank you for watching this video.